Hello students and welcome to the final video of this lesson. I know this lesson has been very long, but we have two more examples to go over, example 7, example 8. So let's get started. All right, here I have example 7. We want to determine the point on the line y equals 2x plus 3 so that the distance between the line and the point 1, 2, which is shown right over there, is a minimum. So of course, we want to circle that because that's super important. So eyeballing this is not going to be very specific. You want to say, okay, which point on here creates that shortest distance? Obviously, it's probably not going to be this one, but it's going to be one of these, points here, and like which one is the shortest line? That's what we're trying to figure out. What's the shortest distance between any of the points on that line and the point 1, 2 that's there? So, this is where, like, when you really need to be specific about like the shortest thing, like this is where calculus comes in handy. So what I noticed is that, how do we find the distance between 2 points? Well, that's the distance formula, the Pythagorean theorem. And that's what we're going to be using here. So if you don't remember the distance formula, that's just going to be the square root of x1 minus x2 squared minus or plus y1 minus y2 squared. So subtract the distance between x and y's, add up the squares, and then take the square root. Pythagorean theorem. So what I want to do is, we know that we have when the value is 1 and 2. So we'll just say that's x2 and y2, or we could say that that's x1 and y1. It doesn't really matter. So let's just go ahead and do that. I'm going to say, all right, we have 1 minus x squared plus 2 minus y squared. And all right, so what do I want to do with that? I want to say, all right, we want to make a substitution here, just like what we've been doing before. Kind of like the last problem in the last video that we did. We have something that we can make a substitution here. We know what y is equal to, so we can make that substitution and go with it. So d equals the square root, and I'm going to actually take this time to expand this 1 minus x squared binomial. So we're going to get 1 minus 2x plus x squared plus 2 minus, and then I'm going to distribute the negative across y. So that's going to be minus 2x minus 3 squared. Okay. Now, again, it's just the algebra, a simplifying. So let's take the time and simplify this. All right, so that's pretty much as simplified as it gets. We can't really find any factors for that square root, which is fine. We can still take the derivative of this using the chain rule. Remember that this is just to the power of 1/2. Okay, so let's take the derivative here and find d prime. Well then, so that's going to be 1/2 times 5x squared plus 2x plus 2 to the negative 1/2. And then times the derivative of the inside, so that's going to be 10x plus 2. All right, so let's say d prime is equal to 10x plus 2 over 2 times the square root 5x squared plus 2x plus 2. And we're going to set that equal to 0. So we've got some additional work that we have to keep going off to the side. So setting this equal to 0, we can multiply out that denominator, so we get 10x plus 2 equals 0. Subtract 2, so 10x equals negative 2, x equals negative 1/5. So that's what we get for x, negative 1/5 right there. We now need to prove that that is a minimum. So let's go ahead and do that. And we are going from negative infinity to positive infinity because we have no restrictions on the domain. So we do just, okay, we'll put in our 0 or our critical value, negative 1/5. So any value less than negative 1/5. So let's just do negative 1. So if I substitute that into my fraction 10x plus 2 over 2 times the square root of yada yada, I'm going to get negative in my numerator. And in my denominator, I'm going to get, it's going to have to be positive. All right, so this comes out to be all negative. And then on the right side, so let's substitute in 0, I'm going to get a positive in my numerator, and then 2 times the square root of 2, that's going to be positive, so positive, positive. So it all comes out to be positive. So this proves that we have a minimum. So let's say this. Distance is at a minimum at x equals -1/5. And the reason we know this is because d prime changes from negative to positive. So let's find our y value. So -1/5. So I'm going to substitute that in to that equation y equals 2x plus 3. So y equals 2 times -1/5 plus 3. So that's -2/5 plus 3 equals y. So a denominator of 5. So that's going to be 15/5. And so y is equal to -2 plus 15. So that's 13/5. So the coordinate that I want is -1/5, comma 13/5. That is going to be the exact coordinate. So if I'm looking here, -1/5, you know, that's like -0.2, and then 13/5. So that's the shortest distance is about right there. You can see that's probably going to be, you know, by the naked eye, pretty close, but the shortest distance on anywhere on that line. And now let's go into our final problem, example 8. So we have a rectangle here, ABCD, with sides parallel to the coordinate axis, and it's inscribed in the region enclosed by the graph of y equals -4x squared plus 4. Basically, look at the picture. So we want to find the x and y coordinates of C so that the area of the rectangle is a maximum. Okay, so we're going to want to maximize this. So we want area to be a maximum, and we want x to be some sort of positive value as opposed to b. We also want our y to be a positive value as opposed to 0, because that would give us d. So in terms of my x, I have x here in the negative direction and x here in the positive direction. So my horizontal distance is going to be 2x, and from my x-axis up to the parabola is going to be y. So how do I find the area? Well, area is going to be equal to 2x times y. Well, can we make a substitution for y? Yes, because we're given the equation in our prompt. So area is going to be 2x times -4x squared plus 4. And let's simplify this. So -8x cubed plus 8x. All right, so what's our next step? We want to find the derivative because we want to maximize. We want to optimize what is happening in this rectangle. So let's find a prime here. I'm going to get -24x squared plus 8, and we're going to set that equal to 0. So I get 24x squared equals 8. Divide that, so I'm going to get x squared equals, that is 1/3, and we're going to take that square root. So x equals the square root of 1/3. And for reasons I've said in earlier videos, you want to think about, okay, why are we just taking the positive square root and not the negative? Well, we know that c is going to be on the right side of 0. So let's now prove that this is a maximum, right? So we're going here, we're going from 0 to infinity. We kind of know this, and I'm going to put in, here's the square root of 1/3. All right, and this is going to represent a prime, and I have my derivative right there. So to the left of square root of 1/3, we know we could substitute in 0, so I'm going to get in a positive value. And to the right of the square root of 1/3, I could substitute in 1, so I get -24 plus 8, which is going to be negative. So since I switched from increasing to decreasing, we know we have a maximum there. So now let's find what is the y value. So let's actually take that time to find the y value. We're just going to substitute x, the square root of 1/3, into our equation right up here for the parabola. So we're going to say y equals -4 square root of 1/3 squared plus 4. And we're going to get y equals -4 thirds plus 4. And if we're going to keep everything as thirds, I'm going to get 12 thirds. So 12 minus 4 is going to get me 8 thirds. So 8 2/3 is going to get me my value for y. So what are we going to finally say about the maximum area? So we know that area is a maximum at square root of 1/3 comma 8/3 because the derivative of a changes from positive to negative. And by calculus, we know that changing from positive to negative gives us a maximum at these coordinates. So we know it's going to be a maximizer of the area. Not sure if those words were properly said, but you guys get the idea. And you can probably tell that I'm a little bit exhausted after going through all these problems just because the algebraic steps is just so intense. But it is very good practice to continue to reinforce your algebra skills. Again, calculus isn't difficult, it's the algebra steps that you have to get down. Calculus is a little bit about memory and application of some theorems, but it's not difficult. You really just have to be really comfortable manipulating equations using algebra. Of course, if you don't understand anything that we did in these two problems, feel free to reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.